All right, for this problem, you're using the fundamental theorem of line integrals as an alternate way to evaluate the line integral for work. The fundamental theorem of line integrals uses your starting point, which is 0, 0, and also your ending point. So it really doesn't matter what the path is, as long as the vector field is conservative, you can take any path. And in this case, the end point is 2, 0. So you're actually plugging in the end point, that's your f of 2, 0, and your starting point f of 0, 0. You're actually plugging these points into your potential function. The potential function f of 2, 0 replaces all those x's with 2's and all those y's with 0. So this does simplify to, in this case, it simplifies to 2. And f of 0, 0, evaluating the potential function at the ending point, is found by plugging in, I'm sorry, I did that backwards. Sorry, f of 2, 0 is evaluating the function at the endpoint, and f of 0, 0 is evaluating the function at the starting point, plugging in 0 for x and 0 for y in that potential function. Actually, that first one should be 2 plus k, and then this one is k. Now, when you simplify, you take the endpoint using the fundamental theorem of line integrals. So it's your f of 2, 0 minus your f of 0, 0, which is 2 plus k minus k, and then this simplifies to 2. Hope this helps.